Alright, welcome to this lesson, and in this video we have to find the dy dx of these functions. The first one is ln x squared and the second one is sine squared x to the power of x all multiplied x. So let's start. We already know how to solve this problem, so let's start. The first one is y is equal to ln x squared, and we know that this can be written as ln x to the squared, and property of log even allows us to bring it back and use product rule, but no need for that. We can use the power rule here, and we can say the dy dx for this function is these two comes down to multiply ln x and multiply by ln x derivative, that is x. So we have 2 all over x ln x. So the dy dx for the function is simply 2 all over x ln x. Thank you. And for the second problem, for the number 2 problem, we have y is equal to sine squared of x cosine of x dot x, and we know that this is a product rule problem. So let us pick our f of x here and our g of x. So we can say let our f of x be sine squared x cos x, and let our g of x be equal to x, and this will imply that our g prime of x is equal to 1, but we cannot easily say what our f prime of x is. So let's work that out and see what it gives us. So we can simply say, and since this f of x equals this, and we can use the applying of ln function to solve this problem. So now let this f of x be equal to h, and this is equal to sine squared x to cosine of x. So let's apply ln to both sides. So we have ln h is equal to ln sine squared x to cosine x, and property of ln allows us to bring this one back. So we have ln of h is equal to cosine of x ln of sine squared of x. So let's solve this quickly using the product rule here and the implicit method here. So here we have 1 all over h dh all over dx, and that's equal to, this is our f of x and this is our another function maybe, and you can call this m of x and our n of x. You just know that for product rule you have to differentiate the first one and keep the second one. So let's do that. So we have this one will give us negative sine of x, and keep the second function sine squared x, plus keep the first function cos x into, this will give us by ln problem 2 sine x cos x all over sine squared x, Now we have to find the h dx, not 1 all over h dh dx. So what do we do here is to multiply both sides by h, and that will give us final answer, the h dx. The x will be equal to h into negative sine x ln sine squared x plus cos x into 2 sine x cos x all over sine squared x. Now that is what we have. Now what's our h? Our h, we already know our h to be equal to this, and that's equal to this. So lastly, our dh all over dx will be sine squared x to cosine x, that's it, into negative sine x ln sine squared x plus cosine of x into 2 sine x cos x all over sine squared x. That is what this man we have. So when we differentiate this man here, just this man here, we got this entire function here, So at the end, don't forget that this function is being multiplied by x. So now we have to use the product rule now at last to solve this problem. So final answer that we know is that is our dy all over dx will be differentiate the first function, and it will give us this man, sine squared x to cosine x into negative sine x ln sine squared x plus cosine x into 2 sine x cos x over sine squared x. That is what that will give us. Now, we define that we keep the second function x, right? Okay, plus keep the first function now, which is sine squared x to cosine x, and define the second function, which is 1. So at the end of the day, this is the answer that we need. Our dy dx for the entire function, sine squared x or the power of cosine x times x. At the end, that is what we got when we define the first one. The first sine squared x to the power of cosine x gave us this result here, and we kept the second one x, plus we kept the first function sine squared x to cosine squared x multiplied by the result of x, which is 1 and times 1. So this is the answer to our problem. Thank you, and see you in the next video.